Today I'm going to talk about numbering systems, and I want to introduce the decimal numbering system and then go on to talk about the binary numbering system, which is used by computers. So the decimal system, let me just get my pen here, is based on 10 digits. Now all numbering systems start with the digit 0. So with the decimal numbering system, it's 0, 1, 2, 3, 4, 5, 6, 7, 8, and 9. Those are your 10 digits of the decimal numbering system. Deci means 10. Bi of binary means 2. So the binary system has only got 2 digits. Decimal system has got 10. So how do we represent a number that's bigger than 9? 9 is the biggest single digit in the decimal numbering system. Well, as you know, we have to use 2 digits. So for 10, we would write 1, 0, and that represents 10. So bear in mind that this 1 on the left is worth 10. 1 times 10 is worth 10. Now if I add a 2 here, so we have got 23, the 2 in this position is multiplied by 10, that's 20, and then we add 3, so it's 23. Now if we get to 99, then here we've got the largest digit in both columns. If we want to represent a number bigger than 99, we'd use a third digit, and then we'd reset the other 2 digits to 0. And as you know, that's 100. So look at these numbers. The number on the far right-hand side, we multiply by 1 to get its value. The number to its left, we would multiply by 10 to get its value. And if there is another number on the left, we multiply by 100. So these columns have a value of 1 for this column, 10 for this column, 100 for the next column, and we multiply by 10 as we go from right to left. So the column here would be 1,000, and the next column would be 10,000, and so on. So, to recap, the value of the digit on the far right-hand side, to get its value, you'd multiply by 1. So, for example, 9 multiplied by 1 is 9. If we have a number like 23, the 3 is multiplied by 1, but the 2 is multiplied by 10 to get 20 plus 3 is 23. Here we've got 99. 9 times 10 is 90, plus 9 is 99. 100, 100, the 1 is multiplied by 100, and the 0 by 10, 0 by 1, so that's 100 in total. Now, the binary numbering system is different. It only has 2 digits. It has the digit 0 and the digit 1, and that's it. These are known as binary digits. There are 2 of them, 0 and 1. And we shorten the word binary digit to the word bit. So the digit here is in this column, these are the 1s. So we've got 0, we've got 1. How do we represent decimal 2? We don't have an extra digit 2. In the binary numbering system, we only have 0 and 1. So just like we did here, once we got to the largest number, 9, we added another digit, so we've got 2 digits. And the digit on the left would then be worth 10. So here, to represent the number 2, I'd have to put a 1 in this column and a 0, and this digit on the left is worth 2. Now let's put the decimal number in brackets on the left here. My writing is not very good. So let's see, the decimal number here is 0. I'll put it in brackets. And the 1 in binary is the same in decimal. And in decimal, the decimal value 2 in binary looks like 1, 0. So how would we represent decimal 3? Well, in binary we would need 1, 2, so 1 multiplied by 2 is 2. And we'd also need 1. 1 multiplied by 1 is 1. 2 plus 1 is 3. Great. So how would we represent the decimal number 4? Well, we've got to our highest number in each column here. This is a bit like 99 in the decimal numbering system. Once you've reached the highest number, then you're going to have a new digit in the next column. So 4, let me get my cursor back there. So for the number 4, I'd have to have an extra digit and reset these two back to 0. This digit here is worth 4, so let's put the 4 there. So how would we represent decimal 5? So if I want to represent decimal 5, I would need a 4 and a 1 added together. That would make 5. So that's 1 times 4 is 4. And 1 times 1 is 1. We don't need a 2, so this is decimal 5. So let's go to decimal 6. 6. Well, with 6, you want a 4 and a 2. So we have 1 4, 1 2, and no 1s. That gives us 6. Decimal 7, we would want a 4, a 2, and a 1. Great. Now we want decimal 8. Now we've reached the biggest number, the biggest digit in each column. So we need a new column, and we'll call that column, if I can get my cursor back up there again, we'll call that column the 8s. And so decimal 8 will need 1 there and 0, 0, 0. That gives us decimal 8. So let's do decimal 9. We need an 8 and a 1. That gives us the number 9. So as you can see, in binary, we always start with the 1 on the far right digit. But here we're multiplying by 2 for each column. So we start 1, the next column is the 2s, the next column is the 4s, the next is the 8. So if we have another digit on the left, that would count as 16. Just as we did here, we're multiplying by 10. We start at 1 and multiply by 10 as you go from right to left. Here in binary, we start with 1 and then we multiply by 2 as we go from right to left. So let's leave it at that point here, and I'm now going to go on to talk to you about a page I've got for you called Numbering Systems, and I'll go and find that one now. Here it is, Numbering Systems. So I've got a link to this one on my website. So numbering systems, this is a review of what we've just done. We're used to the decimal numbering system, which is based on 10 numbers. And just to remind you of how it works, if we've got a number like 125, the 1 on the left is worth 100, the 2 we multiply by 10, and the 5 we multiply by 1. So 100, 2 10s and 5 1s gives us 125. Now if we look at a larger number, 2036, the digit on the far right you multiply by 1, the 3, the next digit you multiply by 10, the next digit multiply by 100, and this digit you multiply by 1000. Add the values, get the number 2036. So the rightmost digit, these are worth 1s. The next is 10, 100, 1000, then it's 10,000, 100,000, and so on. So if you know your exponents, decimal is base 10. And if you're not familiar with this way of representing numbers, don't worry about it. But if you are, 10 to the power of 0, it's got a value of 1. 10 to the power of 1 is 10, 10 to the power of 2 is 100, 10 to the power of 3 is 1000, and so on. Now, as I showed you with binary numbers, we only have 2 numbers, 0 and 1. A 0 and a 1 is known as a binary digit. We call it a bit for short. and there are only 2 bits, 0 and 1. Now here I've got a 3-bit binary number, 101, and this 1, these are multiplied by 1, the next column is multiplied by 2, the next column is 4, and if there was another number here, it would be 8, then 16, then 32, and so on. So this is representing the decimal number 5. You've got 1, 4, no 2's, 1, 1, 4 and 2, 1, 1 gives you 5. And if we have an extra digit, 1, 0, 1, 1, this one you multiply by 1, this by 2, this by 4, this by 8, giving you the decimal number 11. A group of 8 bits is known as a byte. And here we've got a group of 8 bits. And this one represents decimal 0 because they're all 0. This one represents decimal 4. The value of this one here is 4 in decimal. Now the largest binary number in a byte is this number, which represents decimal 255. Now notice the column headings for binary numbers start at 1, then you multiply by 2 to go from right to left. So we're base 2 for binary numbers, so if you know your exponents, 2 to the power of 0 is 1, 2 to the power of 2 is 2, 4, 8, and so on. Now I'm going to skip over octal numbers and go on to hexadecimal numbers. It works exactly the same way. Hexa means 6, deci means 10, hexadecimal means 16. So we've got 16 digits. And so here we've got the hexadecimal digits here. So we've got the digits 0 to 9, just like the decimal numbers. But now, because we need an extra 6, we've got 16 digits, we're going to use the letters A, B, C, D, E, F. So if we look at the decimal equivalent here, just focus on these numbers here. These are the 16 digits of the hexadecimal numbering system. In decimal, 0 is 0, 1 is 1, and so on. But the letter A represents 10 in decimal. B is 11, C is 12, D 13, E 14, F 15. F is the biggest digit in the hexadecimal numbering system. So if you want to represent 16, you need 2 digits. So here we're representing the number 16. So this column here represents all numbers multiplied by 16. The column headings are 1. We always start at 1 for the digit on the far right hand side. In hexadecimal, we're multiplying by 16, and the next column would be 16 times 16, which is 256. So if we look at this number here, 40 in hexadecimal, the 4 must be multiplied by 16 to get 64. 0, 0, so you don't need to do anything there. So the hexadecimal number 40 is decimal 64. Now computers require everything in binary format, that's in zeros and ones. But for a computer it's very easy and quick to convert from any other hexadecimal format, for example, into the binary format. And the nice thing about using hexadecimal is that we only need to use fewer digits to represent a large number. So I'm going to leave it at that point for now, and please review this document, read it again. I've gone through it quite quickly today, and if you've got any questions, you know where I am.